go ahead and get out your postulate sheet that we got from last chapter 2. The chapter 3 postulate sheet, because it's going to talk about most of these that we're using today. Notice all the postulates and theorems in this chapter say converse. What's it mean to be a converse again? Switches the hypothesis and conclusion. So if this, then that, it would be if that, then this. Right? So on here, you saw all the consecutive interior, the alternate interior theorems above. Now we have the converse. It switches them. It said if the lines are parallel, then alternate interior is congruent. Now we say if alternate interior congruent, then the lines are parallel. So it's just the converse of these theorems we did before. The first one, if corresponding or congruent, then the lines are parallel. That's the converse of what we did last time, right? Last time we said if the lines are parallel, then corresponding angles are congruent. It goes both ways, right? Converse is true both ways. And we're not worried about the construction today. And then you had these other ones. Here, alternate exterior. If the alternate exterior congruent, then lines are parallel. If consecutive interior or supplementary, then the lines are parallel. If alternate interior is congruent, the lines are parallel. And if two lines are perpendicular to the same line, then the lines are parallel. So it's everything we did last time, but now it's just the converse. It's switching the hypothesis and the conclusion. Okay. So sometimes I give you the lines are parallel, and I tell you to find the alternate interior angles. And other times I give you the alternate interior angles are congruent and say, can you tell me if the lines are parallel? And you would say yes, because if they're congruent. So for example here, looking at this figure, we want to determine which of these lines are parallel. Of this line A, B, and C. Is A parallel to B, B parallel to C, A parallel to C? Now they look parallel, but we have to be able to prove it. We have to say why, or by which theorem. Okay. So let's start labeling some angles we know here. If this one's 77, what is this one? 77, because they're vertical. Okay. Well, let's just look at line A and B here first. What type of angles are both of these? Consecutive interior. And you know by the converse of the consecutive interior angle theorem, it says if consecutive interior angles are supplementary, then the lines are parallel. Are these supplementary?
Yeah.
Yes. So are A and B parallel? Yes. A would be parallel to B by, that's theorem 3.6. Okay. Let's look at the bottom two. B and C. These are consecutive interior, right? Are these supplementary? No. So is B parallel to C? No. B would not be parallel to C.
Would you still say by theorem 3.6?
Because theorem 0.6 doesn't hold true, right? Yeah, because that doesn't hold true. Because consecutive interior are not supplementary. So if A is parallel to B, but B is not parallel to C, is A going to be parallel to C? No, because they're not parallel to the same line, right? So I would just say these two are parallel by theorem 3.6 because their consecutive interior angles are supplementary. A and B are parallel. And we write that, remember, with the double bars, A parallel to B. So look at these, and I want you to determine is E parallel to F, E parallel to G, or F parallel to G. And is it just one, just two, just three, or all three? So I'll give you a second to look. Here's E, F, and G. So let's just break it down each individually. Let's look at E and F. What relationship on E and F are those two? Corresponding. So if you look at the converse of the corresponding angle theorem, it says if corresponding angles are congruent, then the lines are parallel. Are these congruent? No. So is E parallel to F? No. E would not be parallel to F because corresponding angles are not congruent. Let's look at F and G. These two angles don't have any sort of relationship, so I need to find another piece, right? I could find this piece. What would be this angle? Be 75 because I know these two have to add to 180, right? Because they're on a straight line. So then what relationship do these two have?
Well, they don't, but
These two would be corresponding, right? Right, but they're not congruent. So is F parallel to G? No, because their corresponding angles are not equal. So let's look at E and G. So I kind of have to ignore this line. Two parallel lines cut by a transversal. These two angles don't have any sort of relationship. Like I could find this one, right? Because these two have to 180, they're part of a straight line. So this one would have to be 65. What relationship do these two have? Alternate exterior. The alternate exterior are congruent. So you have a theorem that says if the alternate exterior are congruent, then the lines are parallel. So R and G parallel. Yeah, because their alternate exterior angles are congruent, right? So it would be B. Because their alternate exterior angles are congruent, therefore the lines are parallel. It's just a converse of what we did last time. Questions there? All right. Now I want to find X to make these lines parallel. I want to make line PQ parallel to line MN. I want to make those lines parallel. Find X so that these are parallel. Well, let's look at what it gives me. What sort of relationship are these two angles that it gives me? They're on alternate sides of the transversal. Are they on the exterior or the interior? Exterior. So they're alternate exterior angles. So in order for these two lines to be parallel, what has to be true about the alternate exterior angles? They have to be equal to each other, right? So if I want to find X, I need to find X so that these two things are equal to each other, because then these two lines will be parallel. So I need 11x minus 25 to be equal to 7x plus 35. And I want to solve this equation for X. So I move my X's together on the same side of the equal sign. Gives me 4x minus 25 equals 35. Solve for X. Gives me 4x equals 60. Divide both sides by 4. And X is 15. Because if I plugged in 15 here, this degree measure would equal this one. Because I need the alternate exterior angles to be equal in order for the lines to be parallel. So I just had to do some algebra to make those alternate exterior angles congruent. Any questions? Yep, that point. So like I said, it's just like what we did last time, but it's just the converse of everything. Instead of the lines being parallel, what are the alternate exterior angles? I said, here's the alternate exterior angles, are the lines parallel? All right, let's look at another one. Find X so that those two lines are parallel. Well, these two angles are what? Alternate interior. So in order for those lines to be parallel, the alternate interior angles have to be congruent. They have to be equal. So 9x minus 21 would have to be equal to 7x minus 3. Subtract 7x from both sides, I get 2x minus 21 equals negative 3. Add 21 to both sides, I get 2x equals 18. Divide both sides by 2, x is 9. So if x is 9, this would be 81 minus 20. This angle would be 60. This would be 63 minus 3. This angle would be 60. The alternate interior would be congruent, so then those lines would be parallel. Just the converse of everything we did last time. So now let's look at a proof here. I say given, what does that symbol mean again? Parallel. Given L is parallel to M, so they went ahead and marked it with those arrows. So those two lines are parallel. And also given the angle 4 is congruent to angle 7, so I'll put a little tick mark in both of those. Prove that R is parallel to S. So now I'm going to write a proof, but you guys have been doing proofs on this section the entire time, but you've just been doing it in your head. You've said, I know these are equal because vertical. That's a proof. You said these are equal by vertical angles theorem. You said, I know these are consecutive interior, so they add to 180. That's by the consecutive interior angle theorem. Okay. So we know in every proof we're going to write what's given to us first, right? We're given L is parallel to M. We're given 4 is congruent to X. Well, automatically, since we're given L is congruent to M, that tells us a bunch of different things. It tells us alternate exterior are the same. It tells us alternate interior the same. It tells us consecutive interior add to 180. Because L is parallel to M, that's going to tell us a bunch of different things. Right. So one way I could write next is that 4 and 6 are supplementary. Because I know that, since L and M are parallel, if they're cut by this transversal, what relationship do 4 and 6 have? They're what type of angles? Again, I'm kind of ignoring this line right now. They're consecutive interior. And I know if I have two parallel lines, the consecutive interior are supplementary. So I know 4 and 6 are supplementary by that consecutive interior angle theorem. That's one we did last class. These two would be supplementary because these two lines are parallel and they're consecutive interior. Since they're supplementary, I know they add to 180. That's just by the definition of being supplementary, right? If they're supplementary from this step to this step, 4 and 6 are supplementary, I know angle 4 plus angle 6 is 180. That's just the definition of being supplementary. Remember, if I'm going to substitute into an equation, I need to go from congruent to equal. Whenever we take 4 congruent to angle 7 to 4 equals angle 7, that's by definition of congruency, right? And I could have done this step up here. This step didn't actually have to fall right here. But because I'm probably going to do some substitution, I need to change this to an equal sign to substitute it into an equation. So to do that, to go from congruent to equal, is just definition of congruency. Well, then I substituted because 4 and 7 are equal. 4 and 7 are equal. I can replace angle 4 with angle 7, right? So 7 and 6 add to 180. So these two angles here add to 180. Well, let's look at that a second. If those two angles add to 180, what sort of relationship are they for the with lines R and S? What sort of relationship are 6 and 7? They're consecutive interior, right? So the consecutive interior add to 180, which means they're supplementary, right? Well, if the consecutive interior angles are supplementary, what's true about lines R and S? They're parallel then, right? So that's probably where I'm heading with this proof. Since 6 and 7 are supplementary, or since they add to 180, I know they're supplementary, right? Since they add to 180, I know they're supplementary. Therefore, since they're supplementary, R has to be parallel to S. Because I'm looking at these two lines. These two are supplementary. They add to 180. So since the consecutive interior angles add to 180, or since they're supplementary, R is parallel to S. Yes. Good question. Absolutely. You could have switched those around. No problem. Yeah. But it gave me a bunch of interior angles, so I knew I was probably going to use consecutive interior somehow, right? And I proved since 6 and 7 add to 180, that means they're supplementary. Well, that converse theorem says if the angles are supplementary, consecutive interior is supplementary, then the lines are parallel, so R and S are parallel. So this would be, it's fairly difficult, but this is a sample proof of what you would do to prove lines that are for them to be parallel. Any questions there? All right. So we're going to do some iPad proof here in a second.